Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, Smashing Visibility Silos in Cloud Native App Development, brought to you by Snyk, Datadog, and AWS. We have a great webinar for you today, but before we get started, I do need to go through some housekeeping items with you. First, be aware this webinar is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We'll be sending an email with instructions for how to access the webinar on demand, or you can always visit us at devops.com/webinars, and it will be there for you as well. We will be taking questions throughout the presentation, so use the Q&A tab on your webinar console to submit questions at any time. We'll try to get to as many as we can at the end of the presentation, but rest assured, if we do not, we will gather all of those up and send them over to our presenters. They will be able to follow up with you offline. Finally, today we'll have a poll question as well for you, so please take a couple seconds and submit your response. When you see that come up on your screen, we would really appreciate it. All right, cool. With that, I am pleased to introduce to you today our panelists. Alan Konar is a partner solutions architect with Snyk. Andrew Krug is a technical evangelist with Datadog. And Hanara Hyun is a partner solutions architect with AWS. I am going to turn my camera off and put myself on mute, and I will let you all get right into it. Thank you so much.
Hey, everybody. Happy time zone. Whatever time zone it is for you, as I like to say. I stopped saying good morning and good evening when it's more than 2 continents. And I hope there's lots of folks attending from different areas. So if you could just let us know in the chat maybe that you're here, that you're with us, and maybe where you're coming in from. It's always nice to know that folks are on the other end of the line. So we've got a lot of content today, and we're going to try and stay on track to keep it underneath the 1 hour time that we all have together. This is just a brief agenda. We're going to kind of go through the partnership that Snyk and Datadog have together and how we also work with AWS. We're going to look at the entire software development lifecycle, right? So if you saw the first version of this webinar back in January, instead of diving on just how the tech works, we're going to talk about all these different checkpoints you want to have along the way, not just shift left controls, right? And then we're going to do kind of a similar live hack demo to what we did last time, and then see how we could even improve that story a little bit with some IR and forensics inside of the Datadog platform. Did I miss anything, Alan, Hanara?
Nope, you're right on.
Okay. So like the folks said, this is the 3 of us. I'm a technical evangelist at Datadog. I'm Andrew Krug. Going in order, we'll let Alan just introduce himself real quick here.
Howdy, I'm Alan Konar. I'm a partner solution architect at Snyk. I have the privilege of working with Andrew and Hanara.
And I am Hanara from AWS, and I'm also a partner solutions architect.
Wonderful. So Snyk and Datadog have this partnership, right? And we've been kind of co-working on integrating our 2 sets of products and sort of leveraging the things that are the strongest about them to really deliver what I think is a very unique and cool experience when it comes to vulnerability management, right? So Snyk has this great vulnerability database, right, Alan? I think you're on mute, Alan.
Yes, I am, absolutely. So we have the largest commercial vulnerability database in the world. Last year alone, we uncovered 64 0 days and are constantly updating it. And this database is, or our vulnerability databases are relative to these development technologies, but also to Linux distros, for example.
Yeah, so that technology is actually what's at the heart of our demo, right? Because we couldn't do what we're going to show you today without the great vulnerability database that Snyk has, right? So We're going to take you all the way through how that works, how it can work in CI/CD, but then also how we verify some of the assumptions that we're making in the runtime itself. And I think that's what's very cool about the Datadog Snyk partnership. And also, to some degree, how we partner with AWS as well. And that's we have Hanara here to kind of help tell a little bit of that story, but we have a great story to tell around our integration with AWS and, in this case, Fargate.
Yeah, so Snyk is an advanced technology partner within the AWS Partner Network. That means we've been technically validated to work seamlessly with AWS services. We've earned an AWS DevOps competency and 2 service-ready designations for Lambda and Amazon Linux 2. We are also a private offer-enabled seller in the marketplace that allows our customers to use their existing billing mechanisms, so to pay through AWS, in order to purchase access to the Snyk services. And above and beyond that, we're also contributors to AWS Quick Starts. We've built automated reference deployments. We have 3 of them, 3 Quick Starts that are available for free today. Feel free to take a peek and try them out. Andrew?
Yeah, of course, the Datadog story, when it comes to our relationship with AWS, is really, really similar. We participate in that same enterprise discount plan program as well. We have pretty deep roots when it comes to AWS, and we integrate across, really the entire stack in AWS, giving you this kind of level of visibility, that you perhaps wouldn't otherwise have, logs, metrics, monitoring, tracing, and now, of course, also our great security products as well. So sky's really the limit when it comes to integrating Datadog and AWS. You can have just a little, or you can have the whole portfolio, which is where the platform really kind of starts to shine. So let's talk a little bit about vulnerabilities.
Right on. Thanks, Andrew. If you want to hit the next slide, I apologize ahead of time. This is a build slide, but it is what it is. What we have here is a little bit of background to begin with. So 80 and 90% of code that we see in applications tends to be open source. We're now in an age where folks are building much less bespoke code and really piecing together open source components and writing the parts that connect them. And frankly, it makes sense, right? Why rewrite cryptographic libraries? There's a great chance of getting it wrong. They're very complex. There's a lot of math behind it. There are a lot of good libraries out there to reuse. But the other part that we find is that the rate of issues, vulnerabilities exposed in these libraries is accelerating. It's 2.5 times more last year than it was the year before. And also, the vulnerabilities aren't always obvious, right? You'll have a package that has a number of dependencies, right? Each dependency might have another dependency and another and another and another to nth level. And you could be n levels down with a vulnerability and never have it be easily exposed at the parent package. We found that as much as 78% of vulnerabilities that show up in these open source packages are transitive. So they show up in these nested vulnerabilities. So a part of what Snyk stands for is pushing left with security. So enabling the development groups to be an extension of the security group, but to do that without breaking their workflow, right? We want to be frictionless. So the first step is right here at the code. We have integrations for a lot of the most popular IDEs, as well as our own CLI that you can use in order to test for these vulnerabilities. More importantly, we have a mechanism by which you can automatically fix these vulnerabilities. This is critical because if you look at the cost of remediation, this is from an IBM study. It was IBM Systems Science Institute. They did a study, relative cost of fixing defects. It costs about twice as much to fix in the testing phase versus when you're first doing your coding, and as much as 20 times more once you're in production. So if you want to hit the build, you'll see a couple of examples of this integration that happens. But obviously, the next step is that in the source control side of where we live, so we've been talking about the developers themselves and their IDEs and that direct integration, but obviously you potentially have multiple developers working together, pushing code to SCMs, and that is one of our primary integrations, GitHub, GitLab, Azure repos, so on and so forth. And so again, if you want to hit the build here, what you'll see is that we have this capability for you to do API-based integration using a token or authentication, and then to select which of the source components you want to pull in. So you might not necessarily pull in all of your projects, potentially just the most important ones. If you want to hit the next one, this is where Datadog comes into play. So we co-built a GitHub action that allows for integration between what we talked about earlier, which is this Snyk Intel DB, and well, actually not the Intel DB, but creating a depth graph from the code itself to pull into Datadog itself. You want to hit the next animation. And this is where we're going to focus the majority of this talk on, because if you go to the left where we were talking about SCM, you could potentially, when you're doing SCA or software composition analysis, find that you have hundreds of potential vulnerabilities. What that means is that there are hundreds of packages that have vulnerabilities in them, but you may never call in the method specific to the vulnerability that's called out. And more importantly, vulnerable subpackages may never be touched. And this is the magic, this is the power that Datadog brings, is that they give you a view of the runtime through their composition analysis, and they're able to show you, yes, you have this component that Snyk flagged as being vulnerable, but guess what? The dependency that's specifically vulnerable, it's not called on. We're not seeing it in the profiler. And what that means is that as a developer, you can focus just on those components that have vulnerabilities. They're being called in runtime for immediate remediation. And that means that you can solve more quickly and focus more on development. If you want to hit the next slide, this is basically just a rehash of what I said, which is that the shift left mentality is great, but it's not enough, right? Securing what you build doesn't scale effectively, because as we use more and more of these open source components to build our applications, we're going to find more and more issues, and those issues aren't necessarily, those vulnerabilities aren't necessarily being touched. So continuous security across the entire SDLC enables building securely, and the combination of Datadog and Snyk on top of AWS gives you the ability to ensure that your security group has visibility into these vulnerabilities. If you want to hit the next slide.
So this is kind of where we now are going to start to break down this crazy thing that's called continuous profiling, and understand a little bit of what that is. And thanks for the great setup there, Alan, and like really kind of breaking down the act of software composition analysis. There's a new acronym for me to add to my slides. I'll make a conscious effort to try and break some of them down as we walk through this. So definitely catch me if I use a new acronym as well. So profiling. So we use profiling today to understand how an application is behaving for 100% of requests, right? And this is different than just tracing information, right? Where we're sort of sampling little bits of information about how the application actually behaves itself. In profiling, we actually sit at the runtime level, right? And that's what makes it interesting and different, because we're able to actually measure the amount of time that it takes for a specific function to execute. And so on the left there, you have a screenshot of the Datadog profiler, and on the right, you have a screenshot of Datadog tracing. And you can see how they're quite a bit different, right? Because they have different concerns that they're focused on. So tracing tends to be more focused on what is the external calls that an application is making that might be blocking a request from completing in a timely manner. Where profiling, we're sitting at the operating system level at the runtime, and we're actually able to understand things about the host that we're actually running on, like how much time do the CPU spend on this specific function call? How much memory? Is there chain method executions in there? Are we threading? And this is particularly rich and beautiful in the Java runtime, which we're going to show you today. But we have other profilers as well. So I think this is the first time that we actually get to a poll here. So we want to know what your preferred, maybe not preferred, but like what is the primary language that you're developing in. It could be the primary and maybe not your preferred. Just to see kind of where folks are at. We do this every time we do the webinar. It's always fun to know. So it looks like the polls coming in. Right now, we'll just give like a couple of more seconds for audience interactivity. It looks like we're getting quite a few responses there.
Meanwhile, Andrew, if you don't mind me asking, you noted in your last slide that there's instrumentation that occurs when you're doing tracing that's in the code. So when you're doing profiling, how is that instrumentation applied?
Yeah, that's a really great question. And one of the primary differences, I think, in the way that profilers work, right, is that in the case of Java, we're actually collecting traces from the built-in Java flight recorder, where in some of the other runtimes, we actually patch the interpreter itself. So in the case of Python, for example, we actually have a little C shim that sits in the interpreter that's just constantly monitoring execution calls. So you get all the benefits of profiling without really having to go through and instrument your code, which is quite nice. I'm going to go ahead and close the poll, and we'll see the results. Or I guess we don't see the results on the screen when we do it in big marker. But it looks like Python is the most popular language, with Java being a close second for this audience, which is great because we're specifically talking about the Java runtime today. And then actually after that, it went 38-28, and in third, 24% of the audience says JavaScript, with a mere 7% saying Go and only 3% saying Rust. So always very interesting to hear what people are developing in. So let's just talk about how this thing is built, right? There's a lot of interesting attributes of the way that this app is put together, and this is actually an evolution of an app that Snyk was using for demos before, and we kind of commandeered it for this. If you look at the project structure, and the fork of this project is open source, it's just a fork of the Snyk app itself. It's a to-do list that's written in the Struts framework. You might be familiar with a famous vulnerability in the Struts framework. I don't know if anybody has ever heard about a vulnerability in Struts that caused a large data breach, but bonus points if you want to put the actual incident in the chat. This one here is also built using Docker and also some tools from AWS. In this case, the AWS CDK, or Cloud Development Toolkit, which is a very fun or very cool way to represent infrastructure as code. It kind of sits in that place between declarative and programming languages. So it's effectively just a way that we can represent infrastructure using Python or TypeScript, and then it actually outputs CloudFormation. So the actual architecture is relatively simple, right? We're just running this in AWS Fargate with two containers. One is the actual application itself, and then one is the Datadog Sidecar container. We have this great partnership, of course, with AWS, where we're running a sort of a known good pattern there. So we have separation of concerns between the thing that's actually collecting those Java flight recorder traces and the actual application running itself. And then we're able to leverage things like AWS FireLens for log shipment back to Datadog, which is also a really great way to get logs in and out of Fargate. And that's a great segue to hand it over to Hanara, who's going to share with us some of the AWS DevSecOps best practices.
Thanks for giving that great overview of all our tools and services. So if it's your first time hearing about a lot of these new tools that we're going over, or even some of the AWS services, can definitely seem a bit daunting, and maybe it's like, where do I put all of these services in? So I wanted to take a quick step back and go over a high-level overview of DevSecOps best practices, so we can kind of break down why we're talking about these features and why they're important to have to be able to achieve DevSecOps. Let's go to the next slide. So we have a lot of competing forces to ensure development is quick, operations is stable, and also that infrastructure is secure. So when we're standing up our applications, there is a constant push and pull of trying to achieve a nice harmony with all of these different teams, as well as just making sure that our solution is stable. So DevSecOps is achieved, and we get this nice harmony with all these different components of our solution by integrating and automating the enforcement of preventative, detective, and responsive security controls in the pipeline, which is a lot of the features that we're talking about today. And go on to the next slide. Here are some DevSecOps best practices. Continuous integration, continuous delivery, which Andrew went over. Also having a microservices architecture. So we're going to be using Fargate today. Infrastructure as code. We went over a little bit of CDK, logging and monitoring, which is why we're here with Datadog and Snyk today. And also having a good collaboration and communication with a variety of teams, and a lot of these toolings help us have visibility with each other. And Alan also talked about this a bit, but we don't want to cause so much friction that we are able to abstract but still communicate with each other. So this really allows us to have security, reduce the risk in our solutions, also be able to iterate quickly, so that development piece of being able to develop quickly and have an agile approach, and also making sure that we are able to control and have better operational controls through automation, so it's not something we have to manually keep track of all the time. And jump to the next slide. So I just want to talk a little bit about some of the key security best practices we want to implement in the pipeline, and we can see this reflected in some of the tooling and the demos that we'll be going over today. I want to specifically highlight the infrastructure setup, so pipeline as code, also governance and auditing, and a really big one is logging and monitoring. So we have that visibility, and also have the ability to capture logs that can allow us to trigger events, have a actionable insight, and to really automate how we tackle security risks coming through.
It looks like we may have lost Hanara briefly. Is Hanara frozen for you, Alan?
Yes. Yep. Seems like it on my end as well.
While we wait for her to come back, someone did ask if the slides are available for download, and the slides will be available following the presentation if they haven't already been posted inside of the platform that we're on now. So hopefully there's a slides button, and there may be a PDF there. If there's not, we'll find a way to make those available to you.
Hey, sorry. I had to save the world for a second. I switched into my alter ego, and now I'm back. No, that's always great. We know we're in a new virtual environment when we have to deal with things like this. But I hope we're in this new slide. that's where I thought I got cut off. But just quickly going through these, we already talked about SCA a little bit, fun new acronym to add into our tool belt. So these are some items that we can implement as security within our pipeline. You don't have to implement all of these. A lot of these you want to consider if it's the best solution for you, since it might differ for what your needs are, what kind of overhead you're willing to take on. So a lot of great different types of testing that you can consider adding in. And we'll go over some of these today with our tooling as well. And then let's jump into the next slide. So a lot of little bits and pieces we went over. So I do want to talk a little bit about the challenges that we run into when we try to achieve DevSecOps. And we want to integrate tools that are easy for our teams to ramp up to, and that will actually help us and be a technology that isn't a difficult addition into our pipeline to use. So I have the privilege of being able to work with Andrew and Alan, and they will be going over some awesome new tooling to help build in a better DevSecOps process for all of us today. Another challenge we run into is also being able to view all vulnerability findings from all tools in a simple and cohesive manner, because sometimes if we have a lot of different tools, we have to jump all over the place. But now we have this Snyk and Datadog integration that helps us really tie everything together and be able to iterate more quickly in this way. So that is my piece on DevSecOps, and I will hand it back off to our experts.
Thanks, Sanara. I think it's very cool the way that AWS sort of thinks about security, right? Because we're mostly talking about principles. We're not talking about technology. And I think that there's a perception that just because you can go really fast in AWS, sometimes you have to. But that's not really true, right? It takes time to break these things down. And AWS has all these great tools for kind of thinking about your security, like the tools in Well Architected, the Cloud Adoption Framework, and the NIST framework as well. So if folks want to follow up after the webinar, I'm sure you could point them in the right direction, right?
For sure.
Awesome. So we're using this super cool sidecar pattern that AWS has sort of been wonderfully prescriptive about when working with vendors. So we have this great separation of concerns with the way that we're running the Datadog agent itself from the actual application. So in this case, it's a Java app, and Java has the ability to write out trace information for our continuous profiler via the Java flight recorder. So we just sort of supplement that to parse the data and then hand that off to the Datadog agent, and we get these beautiful continuous profiles. And the results look a little bit like this. This is the shortest trace that I could actually find. And when we get to the actual demo portion, you'll get to see how actually like wonderfully long and beautiful the tracing information actually is when we get to a function call that's way, way down the stack. But what you need to pay attention to here is that we're actually looking at CPU time spent per method call, right? And that gets broken down in that graph there in the center of the screen, and then also a table that you can sort of sort on in a bunch of different ways, and that's kind of the heart of the features in Continuous Profiler. But we've added a whole bunch of decorated information to that, not just for security, also for performance, which is where a lot of this technology started, but we're kind of commandeering it to do some really cool security stuff. And the Snyk integration itself, because you're actually able to run it inside of CI/CD, it runs inside of a GitHub action. The GitHub action is actually using the built-in Snyk native tooling, right? Did you want to chime in here on how that works, Alan?
Absolutely. So the native tooling is focused in this case around software composition analysis, as I mentioned. So we will parse through manifest files associated with a given project. So for example, Docker Docker files, POM.xml, in the Java world, so on and so forth, where dependencies are called out explicitly, and then we'll build an n-level graphing of those dependencies. So, for example, you have project X that's using package Y. Package Y may be using 5 other packages that are called explicitly, and each of those in turn may be calling other packages. So we create a mechanism for visualizing and acting on that entire hierarchy of called packages or dependencies.
Cool. And the output of that is really just a JSON file at the end of everything. I mean, you can get it out in different forms, right? But we're really just running that to generate that graph of direct and indirect dependencies out to JSON, and then we post that to Datadog.
And that's native functionality. So for those who sign up for a free Snyk account and a Datadog account, what you'll see is that once you import your projects into the Snyk account, you'll get a visualization directly in our web-based UI of those dependencies, or alternately, you can do the same thing within your favorite IDE or from the Snyk CLI, which you can install on your host machines.
So the integration itself is relatively straightforward. It's just a GitHub action that you can just take off the shelf and you can throw it in your project. In this case, it's working with the Java apps today. So you have the ability to point it at either a Gradle file or a POM.xml file if you're in a Maven environment, and it's going to sort of automatically do that. And then we have this concept of unified tagging in Datadog, which is a standard set of attributes that we use to describe the environment that something's running in, the service it's affiliated with, and the version. And so those two things put together are what allows our continuous profiler to correlate that vulnerability information. So when we do correlate with tracing, we're actually looking at the function signatures themselves, and we're mapping those to Snyk data. And the result ends up looking a little bit like this. And you'll actually get to see this live in the UI. I just kind of want to pave a little bit of the road from a thought perspective on the information that's actually being surfaced. So we saw that screenshot of a profile of the app before, but then we're decorating that, right? Do you want to talk a little bit about the information that we're decorating it with, Alan, from the Snyk database?
Absolutely. So we talked about one of the values of the Snyk Intel database being its relative size, but there are a couple of others that are also basic to the product. One of which is a view of the maturity of a given exploit for a vulnerability. So one of the things to keep in mind is not all vulnerabilities are built equal, right? You could have the case that vulnerabilities get exposed that are not necessarily exploitable or easily exploitable, and might be exploitable only in certain environments or in certain workloads or flows. So a part of what our Intel team does is track the state of these given exploits and to attach that to the data record. What you'll also find is that if you were to compare, for example, CVSS entry for one of our Intel database entries, that we enrich the data significantly. So whereas CVSS may say there's a problem in X, we actually give context. And so one of the things that you'll find is that Snyk is geared towards the developer community, specifically to keep us from having to be experts on every single package and every single vulnerability, right? The 1 hour that you can spend investigating the problems between two versions of a given dep could alternately be used doing your job, right? Writing code. So that information gets passed along to Datadog, and Datadog is then able to parse and enrich the data that they show in their UI.
Yeah, and I think that the biggest value add here for me is always triage, right? Mm-hmm. Because it's very easy to run a vulnerability scanner against something and just overwhelmed with the pages and pages of information, but actually being able to tie that vulnerability back to a function that's really executing inside of the application, and then use severity as a measure of urgency, I think is incredibly useful.
That's a really, really great point. And also being able to, as we talked about earlier, find the smallest possible remediation, but also potentially mitigation, right? One of the things that's possible is, again, using continuous profiler, being able to see what code is being touched, gives you the opportunity to potentially put into place protections outside of code remediation. Remember that application performance and security run in real time, really. I mean, that's the time scale is seconds, minutes, hours. Whereas on the developer side, even if we put a fix into our code, there's still going to be time in which we have to test it, right? We have to go through regression testing and ensure that we haven't broken anything by adding this fix. Hence, the desire to have the remediation be as small as possible, and to have a partner like Datadog that can identify exactly what needs to be dealt with. That's a wonderful point. Thank you.
Yeah. So as far as the actual profile in Datadog that's annotated with this information, this is the information that's sort of serving as the source, right? So we're looking at the Snyk web UI here, which you also get in the free tier offering, right?
Yep. So this is a visualization that we provide that's the functional equivalent to what you would have found in the JSON file that gets passed to Datadog. So looking through the UI, you're seeing that there are certain packages that are being marked as being vulnerable or containing vulnerabilities, and then a couple levels deep, the actual dependencies that introduce those vulnerabilities, as well as the severity of those given vulnerabilities.
Yeah, and then on the command line, the experience is very, very similar, right? We're just running some of the command, and this is quite small, so like you'll have to forgive me if I'm leaning in a little bit to read it, because it's both a Java app and also vulnerability information, so it's quite dense, right?
And you'll note that there are some additional capabilities, like being able to test for reachability, right? We talked about, I think Nara had introduced the idea of SCA, as well as SAS, DAST, IAST, RASP. And so walking through the vulnerable projects, we're able to potentially identify whether or not the vulnerable component is reachable. That's an example of a form of SAST. Again, with each of these findings, we're able to present, in most cases, a potential fix, right? So here are the items that need fixing. Here are the packages that can provide the upgrade, and in some cases, when there are no upgradable packages, we'll introduce a patch on our own, and that can be automated, that entire process of pushing the fixes. So here we see, again, developer-first experience. Our goal is to seamlessly enable developers to handle security issues before they get passed along. So you'll see that we can prioritize the code reachable vulnerabilities, as I mentioned. Through the UI, you have the capability of filtering. You'll note that we scan for vulnerabilities as well as potential license issues, so you can filter based on one or the other or both, as well as filtering on severity. So Andrew introduced that idea of triage. Clearly, with triaging, you're going to want to sort your actions based on the given risk to your organization. So we would probably filter, for example, on high severity and reachable, and potentially reachable, and identify those issues, as well as filtering on vulnerabilities that have mature exploits. So, say you come up with these 200 potential vulnerabilities. By filtering them down on what exposes you, what provides the actual real risk, we're able to reduce the workload in order to provide an application that could be built with a lesser risk. And the other thing to note is that our prioritization isn't just based on CVSS scores, right? So again, it's based on reachability, of the given vulnerabilities, as well as maturity of the exploits. How possible is it for bad actors to actually reach those particular vulnerabilities within the code? So again, we have the ability to show relative reachability, as I mentioned earlier, so you can actually take a look at what is the vulnerable function. Why is that important? Well, Andrew mentioned this earlier, right? We can take a look at called functions within Datadog and even dive down to the thread level, and that's key, right? Being able to know that a particular vulnerable function is actually being called within a particular vulnerable package. Obviously, if the function is not called, it becomes a lesser priority for us to do some form of immediate remediation. All right, so this is the example that we're using, and obviously to be dramatic, we're telling you you're one vulnerability away from being the next Equifax. What's that mean? Well, I think John in the chat was the first to guess Equifax. Let me just double check. Yep, John called it out when Andrew was mentioning it. Yes, Equifax was hit by the Struts vulnerability, CVE 2017-5638. They were using Struts, which is an MVC Java framework for web-based applications. It was incredibly popular. This is 2017 or so. Because it made things fairly simple, but because it was popular, of course, it was also a popular target for bad actors. At the time, at least half of Fortune 100 companies were using Struts-based applications. And the first time that a vulnerability was called out was in the Jakarta multipart parser in March of 2017. Something interesting to note, and this is not uncommon, that vulnerability existed for some time. It wasn't publicly published until well afterwards. And there are a number of examples of that sort of a vulnerability. I mentioned one earlier, Heartbleed with OpenSSL existed from 2011 or 2012 until 2016 and wasn't unearthed until 2016, 2017. This particular CVE calls out a class of a bug that enables remote code execution. So it allows bad actors to run arbitrary code on the servers that are vulnerable, the ones who are using these vulnerable components. And that means that they get access potentially to PII, customer data, company-sensitive information, so on and so forth. The specific mechanism here, and I'm talking about this now because you're going to see an example as we move along, is that you can inject invalid content type headers. So in your HTTP headers, you have the content type, content length, so on and so forth. Content type and content length are two wonderful sources of targets, right? Because there's interesting things you can do when there's not validation in the parser itself. So, for example, content length, you can specify a length and have it not actually be true and have parsing happen. But in this case, it's content type, where we can specify an invalid content type, and the headers, they don't get processed as plain text, right? There wasn't any validation or cleaning that happened, and so they got parsed as OGNL code. That means that the native payloads that were included were converted to executables, and by virtue of how the uploader worked, they were dropped in the temp directory. And there's a lot of wonderful stuff that you can do when you can drop arbitrary code into the temp directory. So why is this important? Well, this Struts breach, the CVE 2017-5638, it exposed sensitive data for at least 150 million US consumers alone. At the time, they were estimating about 200,000 credit cards were stolen through this one vulnerability. Effectively, you had this remote code execution vulnerability that was exploited because it wasn't patched. And this is the interesting thing, is that if you're doing software composition analysis or SAST or DAST or whatever else, and you unearth these issues, that doesn't necessarily mean that you will remediate them or even mitigate them. And that was the challenge here, is that this unpatched flaw was allowed to sit for a significant amount of time. It took 2 hours or so from the public disclosure for pretty mature exploits to emerge in the market. And it took Equifax 2 months to disclose that they didn't fix this vulnerability and that they had been hacked. Again, once you have a vulnerability with a mature exploit, then any script kiddie is able to take advantage of it. That means that it becomes a much larger target. So here we're taking a look at a chart from one of the reports that came out around the timelines. You'll note that sharp rise within a couple of hours of the vulnerability being exposed. The distribution of attacks, if you look at it, they sort of go down as responsible agencies patched their own given systems. But it's easy to see how quickly bad actors were able to weaponize this given vulnerability and target servers of organizations that had valuable information to them. So this is an example of one of those vulnerabilities, the arbitrary code execution based one. You'll note that we specified it as a high vulnerability. So from the CVSS, you had a 10, but we went further and indicated that because there were mechanisms for weaponizing the exploit freely available using Metasploit or any of a number of your favorite tools, whatever they might be, that meant that this particular vulnerability was especially critical. And in fact, we would mark it, nowadays we would have marked it as critical. At the time, high was our highest indicator.
And so let's actually see it in action, right? Because I think that's one of the coolest things about this is how easy it was to actually perform the exploit, which is why we saw such rapid weaponization, right?
Absolutely.
So I've got a little demo here, and I'm gonna share the entire screen. I'm gonna be extra brave. And we're going to go ahead and look at the exploit first, and then we're going to go and run it. So the first exploit that we're actually going to run is actually going to just put the Struts exploit headers through a curl here. So you can see it's pretty easy. And then we actually just have the arbitrary command that we're going to execute on the server itself. And then we have the Java goof app here, just as an environment variable that I've already kind of set in my shell. So I just clear the terminal, and hopefully this is a good font size for everybody. It looks relatively large and sharp. So here I've got just Java goof app set, or I guess I have to source it. Struts aliases. Let's see what the actual environment variable even is. So it's Java goof host, not Java goof app, of course. There it is. And if we were actually to go and just visit this in a browser, it's just a to-do list app. It's a cute little app, right? And it even works. You can sign in, you can sign up. It's live online. So the first thing that we're actually going to do is we're going to run that Struts exploit, right? And you're going to see it actually is dumping out the environment on the actual node itself. It is of note that because we're using that sidecar pattern here, we're actually not leaking any secrets in the environment, but we could, of course, always pivot to the Fargate metadata server and get a set of AWS credentials that we could exfiltrate that would be good for 15 minutes for us to go and do some additional reconnaissance. In addition to that, we can also use the zip slip exploit, which is a Python file here that actually just uploads an arbitrary file into that temp directory where then we can actually go and execute it. So not only do we have remote code execution, we have the ability to get a malicious binary onto the box itself. So we can run that as well. And of course it will work. And we'll see the artifacts of this in Datadog in just a second here. So popping back to the browser here, if we actually go into Datadog for this, you can see that we've been getting continuous profiles for the app all along here. And this is what they end up looking like. You can actually drill down in the analysis as well. And if this specific function that's being executed here had mapped to some vulnerability information, we'd see that decorated information here in this interface. But I think one of the call outs here is that this gets richer and richer all the time, including that we have the performance fix information as well. So if you're using a version of the Java runtime, for example, that doesn't have performance fixes, we're not just calling out security information, we're calling out everything that's kind of interesting that has to do with that profile. As far as the security information goes, it ends up looking like this, which is that we have vulnerability intelligence brought in from Snyk, and then when we actually click on those, it takes us out to the Snyk database, and we can see mitigation information, remediation information, severities, any other reading that we could do to help us kind of make the right decision when it comes to managing that in our environment.
And again, that mitigation versus remediation is key, right? Mitigation is real-time or near real-time. That is where, for example, AWS comes into play. You can take advantage of any of a number of application security interfaces that are available there, whereas remediation falls into Snyk's bucket, and it's Datadog that ties all of this together.
Yep. So so that's just kind of the high level of how that is working. Of course, we can do everything else in Datadog, which you'll see at the end of the presentation, to sort of also do some additional forensics on this. And I think that that is one of the cooler things that we can do here as well. So I'm going to stop sharing that for now and also just switch to the AWS account that's running as well, because I just want to kind of call out here that we're not just getting vulnerability information from Snyk, we're also getting it via the Fargate, which is also a great way to see vuln information. So if we go to that here, switching to ECR, because we are using the native Docker repository in AWS as well for every image that's pushed. We also have some vulnerability data here as well that we can use to not just trust CI, but also verify that in the repository itself using another type of scan. We can also see CVE information here as well. And then we're seeing that surface in Datadog. So we have all these checkpoints along the way, and then Datadog to aggregate and roll up all of that data for us. So I'm going to switch back to the slide deck now. Trying to stay on time here. So, like we mentioned, we're saying one vulnerability from being one vulnerability away from being the next Equifax, but really, you know, that's probably quite true for a vulnerability of high, like a maximum severity, like the Equifax one. And the more intelligence and visibility we have to surface that for us, like if you're using software composition analysis, the faster that's going to be remediated, because you have more eyes on the same issue and not just from a dedicated security team. You're going to have eyes from operations, eyes from software engineering and development teams. So it's really a way of kind of leveling the playing field and making everyone responsible for doing security, which is a big theme, right? And we have just a little bit more time left, so I wanted to show you too how you can tell a little more of the story using Datadog. So I'm just going to pull the tab in here to the presentation window. Right, so continuous profiles are just one part of the picture, right? So if things are actually exploited, we want to actually know from the host perspective as well, kind of what's going on, and the way that we can tell more of that story is, of course, with log data. So in this case, like I mentioned, we are using FireLens to bring in the log data. We also have CloudTrail data coming in, so we have that to be able to understand if the attacker is using those machine level credentials to try and pivot into other places in the cloud environment. But we can also gather the logs from Tomcat itself. And you can see that this application like sort of embodies the inadequate logging call out in OWASP. But the fact that we do have these logs and stack traces as part of it do show us, for example, for this was actually the call out that we had loaded an arbitrary executable onto the box, and then it gets cleaned up by a resource bundling process. So we can follow this all the way through, and we can also pivot to the other containers, or we could actually view this in context, which I think is very helpful for managing a security incident, right? Because you're always thinking about kind of a start time and an end time for an incident, and maybe you don't just want to see this application only, you want to see it in context with the other things that's going on in the environment that involve that specific service. So being able to kind of jump back and forth between those things is really, really useful. And of course, if we saw a behavior that we wanted to alert on, we could parse a little bit of the message, and then we could come in here and we could actually use Datadog's monitoring platform to write a security alert rule in the security signals product to hit on something like that. So we have tons and tons of really useful rules in here already, but it's very, very easy, for example, to write rules on the fly in an incident and see if someone's doing reconnaissance, for example, where you can pull in literally any log or anything that exists in Datadog and then set very simply using math or just expressions in the rule cases, different triggers and different severities. And then, of course, you have the ability to send those out to things like webhooks if you want to do SOAR functions, or you can send them to Slack or PagerDuty, anywhere you want, and write out an entire run book for your team to work off as they're sort of working through managing that security signal. So you can really do it all.
Awesome. You are like, that was perfect, Andrew. Thank you. I didn't have to cut you off at all. Unfortunately, folks, we're coming right to the top of the hour, so I do need to start my wrap up here. That was amazing. Such great content. Thank you all so much for that. Folks in the audience, thanks for tuning in. As a reminder, this was recorded, so if you missed any or all of it, you'll be able to go back and watch it again. We'll be sending an email to you with instructions for how to access it on demand, or you can visit us at devops.com/webinars. It's there for you as well. And I see Andrew's put up some follow-up resources on this slide for you. The other thing I need to do is hand out our Amazon gift cards to their winners. I went ahead and drew those just now. So congratulations to our 4 winners today. They are Kathleen F., Julie H., Bruno C., and John W. Congratulations to all of our winners. You'll be getting an email with instructions for claiming your gift card. If you don't see it in your inbox, please make sure and check your spam folders. So thank you so much to our speakers and our audience. We really appreciate your time today, and we hope to see you again soon at another DevOps.com webinar. I am Sharon Florentine, signing off.
Thank you.
Thanks, Sharon. Thanks, Alan.